Welcome back, everyone, to another Explainer. I am so thrilled you're joining us today because we are diving into something completely foundational, super exciting, and honestly, just absolutely essential in the world of cybersecurity. We're tackling Module 02, setting up your hacking lab using VirtualBox and Kali Linux. Look, before you can launch a single exploit, scan a network, or even think about analyzing malware, you absolutely must have a secure, completely isolated environment to practice in. And today, we're going to build that exact environment from the ground up, right here, right now. But right off the bat, we've got to address the elephant in the room. How do you actually practice hacking safely and, more importantly, legally? This isn't just some abstract technical question, it's a massive legal one. Running offensive tools on a live network, your school, your workplace, or even just your home router, it carries incredibly high stakes. A single misconfigured command can literally take down an entire network. And trust me, ignorance is not a valid legal defense. To get a feel for what we're aiming for, think about this brilliantly simple metaphor from our training sources. Picture yourself in an empty mall parking lot at dusk. You've got cones set up, there's plenty of space, and absolutely no real traffic to hit. That is exactly what a hacking lab is. It's your safe sandbox. It gives you all the room in the world to make mistakes, stall the engine, run the wrong tool, whatever. Completely isolated from real-world traffic. Okay, let's dive into this. Here's our roadmap for today. 1. The need for a lab. 2. VirtualBox basics. 3. Introducing Kali Linux. 4. Step-by-step setup. And 5. Optimization and safety.
Section 1. The need for a lab. Why safety really matters.
So, a hacking lab is essentially a secure, isolated, and legal environment strictly required to test malware and practice tools without damaging production networks. Think of it as your digital quarantine zone. Laws like the Computer Fraud and Abuse Act here in the US and similar laws globally, well, they really don't care if you were just experimenting. Without a dedicated lab, you are flying blind in some seriously dangerous airspace.
Section 2. VirtualBox basics. Let's put a fence around your lab.
To build this fence, we use a neat piece of technology called a hypervisor. A hypervisor is simply software that allows multiple simulated environments, or virtual machines, to run on a single physical computer at the same time. And it's pretty cool to note that since version 6.1, VirtualBox exclusively uses hardware-assisted virtualization. This means it talks directly to your CPU's virtualization features for just incredible performance and rock-solid stability. Think of this core architecture like a strict border control. On one side, you have your host OS. This is your everyday computer, the hardware you're actually touching, maybe running Windows 11 or Mac OS. On the other side is your guest OS. That's the isolated system running inside VirtualBox, which in our case is going to be Kali Linux. The hypervisor acts as the border patrol right between the two, making absolute sure that whatever happens in the guest OS stays completely trapped inside the guest OS. Now, we're choosing Oracle VM VirtualBox for this for a few really key reasons. First off, it's a free, open-source Type 2 hypervisor. Type 2 just means it runs as a normal application right on top of your existing operating system. It's incredibly versatile, too. It runs seamlessly on Windows, Mac OS, Linux, and even Solaris. It really is the perfect, cost-effective tool for desktop virtualization.
But whatever you do not want to skip this next crucial add-on, the VirtualBox Extension Pack. While the base VirtualBox software is open source, this proprietary add-on unlocks some absolute must-have hardware functionality. It gives your virtual machine support for USB 2.0 and 3.0 devices, allows host webcam pass-through, enables VirtualBox Remote Desktop Protocol, and even allows for AES disk encryption. Basically, if you want to plug a physical Wi-Fi adapter into your laptop and have Kali Linux actually recognize it, you need this pack.
Section 3. Introducing Kali Linux. Time to open up your penetration toolbox.
Okay, so now that our parking lot is fenced in with VirtualBox, let's look at the car we're actually going to be driving. Kali Linux is a highly specialized Debian-derived Linux distribution maintained by Offensive Security. And it is packed. It comes preloaded with over 600 penetration testing, digital forensics, and security auditing tools. We're talking industry heavyweights like Nmap for port scanning, Wireshark for packet analysis, John the Ripper for password cracking, and the Metasploit framework. But I really must stress this. Kali is just a highly specialized toolbox. It's not some magic hack button. It still absolutely requires a skilled operator.
You might be wondering, why don't we just use Windows for all this?
Well, here is a pro tip. If you try to download offensive security tools on Windows, Windows Defender is going to immediately flag them as malware and delete them. Plus, Windows totally lacks native support for advanced networking tasks like packet injection, and it just doesn't offer the deep, raw terminal control that a Linux environment naturally provides. Kali is built from the kernel up specifically for this job.
Section 4, Step-by-Step Setup. Let's get into the practical implementation.
Here is our high-level roadmap to get things running. We download VirtualBox and Kali, configure the hypervisor, import our machine, set up our network, and boot it up. And I have a massive time-saving tip for you here. When you go to kali.org to download, grab the pre-built virtual machine image, the .ova file format. By importing this appliance instead of using a standard installer ISO, you completely bypass the long, tedious manual installation process. It's basically plug and play. When you import that image, you're going to need to tune the virtual hardware. And it's vital to understand the balance between your host machine's total resources and what you're giving away to the VM. Ideally, your main host computer should have at least 8 gigs of total RAM so you can comfortably hand over 2 to 4 gigs specifically to Kali. You'll also want to allocate 2 CPU cores. This ensures that multi-threaded tools like those brute forcers run smoothly. And finally, max out the video memory to 128 megabytes and enable 3D acceleration to keep your interface nice and snappy.
That brings us right into our networking strategy, which is absolutely critical for your safety. You basically have 3 main choices here. A NAT network places your Kali machine behind a private virtual router. It can reach the internet but keeps you safely contained in the parking lot. Now, a bridge network, on the other hand, pulls a real IP address directly from your physical home router. This exposes your VM straight to live traffic in your real local network. Useful sometimes, but risky. But if you're ever analyzing live malware, you will want a host-only network. This completely cuts the VM off from the internet while still letting it talk safely to your host machine.
Section 5, Optimization and Safety Rules. Let's boot up and lock down.
Okay, notice this really important shift in the default credentials. If you watch older tutorials online, they might tell you to log in as root with the password Tor. But ever since the 2021 release, Kali shifted over to a non-root user policy by default. So your login for the pre-built VM will simply be the username Kali and the password Kali. Just be aware that some of the built-in tools also have defaults, like Beef using Beef for both, or MySQL defaulting to a root user with a totally blank password.
Once you log in, the very first thing you need to do is open up your terminal and run 2 specific commands. sudo apt update, followed by sudo apt upgrade-y. The update command reaches out and fetches the absolute latest package lists from the official repositories, and the upgrade command actually downloads and installs those fresh new versions. Doing this ensures your tools are secure, fully patched, and functioning perfectly right out of the gate.
Now, the second you are updated, you must immediately take a snapshot. Think of a snapshot as your ultimate foolproof undo button. It perfectly preserves your exact settings, your virtual disks, and even your memory state in that exact moment in time. If you accidentally break your system messing around with root privileges tomorrow, or say you accidentally detonate malware inside your lab, you do not have to reinstall everything. You just click your clean base snapshot, and boom, you are instantly reverted to a perfect state. It's a lifesaver. As we wrap up this setup phase, I want to leave you with a really vital piece of advice from our sources. Quote, Kali is just Debian with tools. For a beginner, there's no advantage unless you intend to learn those tools piece by piece. End quote. Please don't get overwhelmed by the 600+ applications sitting in the menu. Your ultimate goal in this new, isolated parking lot is deliberate practice. Focus on one single tool at a time, deeply understand how it works, and never, ever point it outside your authorized lab environment. And that brings us to the end of our setup explainer. You've got the knowledge, you've got the safety protocols down, and you know the step-by-step architecture. So I just have to ask, what is going to be your very first practice target in your brand new, legally compliant sandbox? Go ahead, boot up VirtualBox, make sure you take those snapshots, and have a happy and ethical time hacking. I'll see you all in the next explainer.